Hello everyone, in this video we are going to discuss applied chemistry for CSE stream module 1. These are the four most important and repeated topics in the previous year examination and also mentioned in the model question paper. So starting with the first question, what are batteries? Explain the working principle, properties, and application of quantum dot sensitized solar cells. This is the most important question. It's asked every time in the video examination. So battery is a device that stores chemical energy and converts it into electric energy through electrochemical reaction. It converts the chemical energy into electrical energy through electrochemical reaction. Okay, so quantum dot sensitized solar cells, also known as QD-SEC in short form. Definition for quantum is this device uses quantum dots few nanometers in size with unique optical and electronic properties. This has unique optical and electronic properties which absorbs solar energy and converts it into electrical energy. So basically this is a device that converts solar energy into electrical energy, as we have seen in many of the farms. Okay, so here they are asking for construction properties and principle. Okay, construction. Quantum dot sensitized solar cell consists of three parts mainly: for photoanode, electrolyte, and cathode electrolyte. Okay, photoanode is placed in the left side with the quantum dots coated, and it is of TiO2, means titanium dioxide. Okay, here we can see here in the diagram, these are the quantum dots, small dots here, and inside we have photoanode. Okay, electrolyte for polysulfide used to transfer holes from the quantum dot. Here we are using polysulfide to transfer holes from the electrodes. So the holes are positively charged. To transfer that we are using polysulfide, which is given by electrolyte. Cathode electrode. This completes the circuit by regenerating the electrode. As the holes get transferred, the cathode electrolyte regenerates the electrolyte. Okay, so this diagram is important. You need to draw the diagram. Invigilators mainly look into the diagram and they ignore the theory part most of the time. So you look after the diagram. Okay, so moving to the next part, which is working. Here it works as a solar cell. Okay, we have seen in farms and all, or in heat places. Okay, quantum dots absorb sunlight. So the quantum dots absorb the sunlight. Existing electrons move from valence to conduction bond. So we need conduction of electricity, right? So the electrons move from valence bond to conduction bond. Electrons are transferred to semiconductor. From conduction band, they are further transferred to semiconductor, leaving holes on the quantum dots. So holes are positively charged, so they are left in quantum dots only. Okay. Now electrolyte absorbs hole and is reduced. So the electrolyte is initially negatively charged. Since holes are positively charged, the electrolyte absorbs the holes and it is reduced. So we need to write this reaction and highlight this. See, we can see S raised to 2 minus. Minus means electrons. As the holes are positively charged, it gets reduced. So we need to write the reaction. Okay. Electrons flow from anode to cathode. The electrons were sent to semiconductor. Now further they are they flow from anode to cathode for external circuit. Here is the external circuit, right? For external circuit, they move from anode to cathode. At cathode, electrolyte is regenerated. As here it is mentioned, cathode electrolyte regenerates the electrolyte. So yeah, at cathode, electrolyte is regenerated, and this is the reaction. Okay, so it will be negative, and again to make it negative, we are adding two electrons. Initially, electrolyte was in a negative form, right? So to make it negative, we are adding two electrons additional. This is the diagram you need to draw, or else you can create your own diagram if you think this is a bit complex, or it would be better to draw this diagram only. Okay, so moving to the next question. So the next question is, what are actuators and transducers? Explain the detection of glyphosate with electrochemical reaction. This question is also asked many times, so look to it. Actuators. Actuators are devices that convert energy into mechanical motion, like motors, hydraulic cylinder, and transducers, devices that convert mechanical motion into another form. Best example for this is microphones. Okay, and you can write these both examples also. Detection of glyphosate by electrochemical oxidation. Here we are using a sensor. The main thing is sensor and electrode. Silicon based chip with 3 electrode system. Here we are using silicon based chip with 3 electrode system. Electrode setup is we are using 3 electrodes: working electrode, counter electrode, and reference electrode. Working electrode and counter electrode both have gold electrode. The specifications are 4 millimeter diameter and 200 nanometer gold nanoparticles. Okay, these both are same. Just for reference, we are taking 3, and the reference electrode here we are using AgCl. AgCl, which is Ag means silver. Here, working and counter electrode we are using gold, and reference electrode we are using silver. Okay, electrolytes. Additionally, electrolytes are added to improve conductivity and reduce resistance. As we are going to judge the detection of glyphosate based on current, so we are adding electrolytes. So the working principle here is we are connecting a 0.78 volt to the working electrode of potential to the working electrode. Glyphosate oxidizes on the working electrode. Glyphosate is oxidized on the working electrode, changing the current. So the change of current defines the concentration of glyphosate. This is the reaction we need to write for reference purpose, and it carries marks. Okay. So moving to the next question. So coming to the next question, it is explain the working principle of electrochemical sensor and its application. This is the same that we have discussed here, electrochemical oxidation. Here also we are using these 3 sensor electrodes. Okay, here electrochemical sensor. These sensor use electrodes to detect substances. The key components are working electrode, electrolyte to increase the conductivity, counter electrode, and reference electrode. And you can also write the composition like we have written. Working electrode and counter electrode uses gold, and reference electrode uses silver. Okay, so the working process is the substance moves to the electrolyte interface. It sticks or absorbs to the electrolyte surface. An electrochemical reactions occurs with electron transfer. Since the electron gets transferred, the electrochemical reactions occurs. The product is released, means the product is deabsorbed. Before it was absorbed in the second step. In first step, it gets deabsorbed after the electrochemical reaction occurs. The product move away from the reaction area. These are the 5 steps of working process. Here, application. Where is electrochemical sensors used? Oxygen sensors for boiler waters and hydrogen fuel cells. So it is used in oxygen sensors, and toxic gas detection in security and defense, like the toxic gases that are thrown by the enemy. These are used in defense. Water and environmental monitoring. So to detect chemical increment and decrement in environment, also we are using this. Healthcare diagnosis to measure a patient's health condition. There we are using soil parameters. So the condition of the soil, we are using this. These are the 5 applications. Just remember the key points. Okay. Moving to the next question. Describe the construction, working, and application of sodium ion batteries and mention any 4 applications. Okay. So sodium ion batteries. Sodium ion batteries composition consists of 5 parts: anode, cathode, electrolyte, separator, output voltage. In anode, we are using carbon. In cathode, we are using NaCO2, which means sodium cobalt oxide. In electrolyte, we are using ethylene carbonate, diethene carbonate. Okay, these 2 substances are using in electrolyte to increase the conductivity. Separator, we are using polypropylene. Output voltage we are getting it is 1.85 to 3.45. These you need to remember. This is the 5 composition of the sodium ion battery. Okay, so the working of sodium ion is simple. We need to charge the sodium ions Na plus and move it to cathode to anode, and these are the cathodic reaction, anodic reaction, and overall. Even if you are facing problem, you can write the overall reaction rather than writing both, but it is referred to write all the 3 reactions. So depends on you how you want to write. Okay, so while discharging, it is pretty simple. Like the sodium ions moved from cathode to anode, right? So they're coming back from anode to cathode. This happens in our mobile phones also. So when we are using the mobile, that then the sodium ions are getting transferred back to cathode. When we are charging, the sodium ions are getting charged and moving to anode. See, this is all the three reactions. In anode, what is the reaction getting, and the cathode, what we are getting, and overall reaction. For both also you can write overall reaction, but it is referred better to write all the three reactions. So applications of sodium ion batteries. Coming to the applications, we have the sodium ion batteries are used in electronics, computing, and aerospace. Electronics, mobile phones, cameras, calculator, LCD TV, etc. And computing, laptop computers, aerospace used in various applications. You can write. These are the three applications. And similarly, lithium ion batteries is also asked in VTU. Just remove the Na here and add Li. Okay. So if you want this PDF, just comment down. I will provide you the link. Okay. Thank you.